Hey everyone, and welcome to another video. This video is going to be fairly quick. In this video, I want to only demonstrate the gait analysis, and this uses DeepLabCut. In fact, I'm using their foundational SuperAnimal model, the top view mouse model. And from this analysis, what you can sort of try to understand is the posture variation. Gait analysis is foundational for many research investigations, including neurodegenerative conditions. And by looking at the different variations and the phases, the lag and leading phase of the animal's uh, hind legs, we can determine how much asymmetry is present in the movement of the animal. So basic gait analysis just allows us to track different body parts and to be able to calculate metrics that may reflect the variability in the posture from a control group. Okay, so with that out of the way, feel free to check this repo out. I will leave the link for this down below. There are lots of different metrics that this extracts, and I will simply just demonstrate the pipeline so you can get a feel for it. And if you do end up using this project, please make sure that you understand that this project is inspired by this publication. And many of the definitions that I've used in this project directly come from this publication. And therefore, please, I highly encourage you to cite them and this repo if you end up using this for your research. So without further ado, let's jump over to Visual Studio Code. As you can see, I've already run one cycle of my analysis. So here I'm going to go over to configuration.py file. I have my environment, Anaconda environment selected in the Visual Studio Code. You can, of course, do this from the command line as well. In the configuration file is where you need to define your input path for the video and the input for the DeepLabCut CSV. You do need to define regions of interest if you're going to be doing that. However, it's not mandatory, and you can skip that step at the command line interface. The key points that you're going to be tracking, in my case, I'm using the SuperAnimal top view mouse model from DeepLabCut. It's one of their foundational models, works really well out of the box. So that's what I've been using here. And those are the key points that it tracks. For the gait analysis, please define your parameters, the body parts that you're going to be tracking. It does require you to use 4 different body parts. Could be all 4 of the paws. In my case, I'm using the left shoulder, left hip, and right hip, because these are the body parts that the foundational model tracks. It doesn't track paws, but I'm using these as a proxy. Then please determine for your confidence level how much paw speed threshold you want to maintain. So it will track a paw or the body part above that certain threshold of pixel movement per frame to then be able to use it for the gait analysis. A few other, kind of numbers that you can manipulate, and all of the documentation is up to date in the GitHub repo right here. So feel free to scroll down here and read over those metrics. So to simply run this, make sure you put in all of these parameters in the config.py file, and then you're going to navigate over to the main.py file and then run this from a command line interface. Here, this is my first time it's asking me to draw a region of interest, but before that I have to name it. I'll call this one center, and then go to this this pop-up window, and then input my region of interest, something like this. I don't have to connect this last part, and I'm just going to press C to confirm. It's now asking me if I have any other region. Let's do one more region, ROI number 1, or rather number 2. Then going back here, and I will let's do this corner. There's absolutely no meaning to this. I'm just randomly selecting a place to put. And then if I'm done, I will just press enter, and it will save the JSON file with the names of the regions of interest. Okay, and these can be called in automatically from assigning the configuration file. So here I can give it a path if I already have my region of interest saved. Okay, so at this point, it's going to go ahead and do the analysis. I'll pause the OBS here and then come back once the analysis is finished. All right, so the video dashboard has been generated and the results are saved here. There are 3 files that get generated. The gait analysis summary provides information for each of the strides. Okay, so what frame it started at, what frame it ended, the stride length, the stride speed, and if it is able to calculate, then it will calculate the stride step length. So step length and the step width. So that's saved in the summary file. Final analysis includes a bunch of extra data like this. So there is per frame level data available. And then scrolling all the way to the right, you can also get per paw, per body part information that is used for tracking the strides of the animal, and then the phases where the paw is in different phases, and we can understand certain qualitative aspects of what the animal is doing. Now, one aspect of this project is that for all the empty frames where detection is not happening, it will automatically assign that to be a swing. Okay, so when you're reanalyzing this or using this for downstream analysis, make sure that you get rid of all the empty frames where the animal is not in the environment where you expect it. Okay, so that's that. The filtered data set is used to create a stride visualization. And in fact, I'll go ahead and run this one. And this should get done while I show you the video, the dashboard style video that got generated. So this one has 2 ROIs, both are in blue on the left side here. So as I scroll through, you can see it's calculating different metrics, the entries. So top ROI was ROI number 2. When the center of mass of the animal enters that region of interest, it marks that as an entry and calculates how many frames the animal is spending in that. So this is the dashboard style video that gets generated. All the analysis is saved here in these files. The other video that gets generated is a stride level visualization for verifying each of the strides. So here, for example, the animal, as it's moving its hind paws, or in this case, I'm just tracking the hips. When the animal's hips are moving in a way that represents the stride of the animal, then the counter carries that over and it shows the accumulated steps. So here the animal is going in circles. Let's fast forward to this frame. Okay, so those are the 2 things. Both of the videos are generated for sake of verification and really making sure that the body postures align with the data that you're seeing. In the future, I am planning on implementing a few more analyses. These are yet to be implemented, but these are good to have. And these are for my personal use, but I will make those available to whoever wants to use this. Interpaw coordination, excellent for giving information about walking, trots, bounding behaviors. Okay, so incredibly useful for neuromuscular coordination analysis. The duty factor, this is proving harder than I expected, but it allows to allows a person to differentiate between stable walking gait and a dynamic running gait. And both of those can have different variations based on whether you're looking at an animal model of, let's say, neurodegeneration, where the gait is expected to be altered, or maybe early stages of neurodegeneration where the animal is still able to run, but the run has some variation in the posture of the run stance compared to a control group. So those type of things can be, the duty factor can be extremely easy measure to compare two groups with each other. Base of support, I think this is a neat idea where, if you draw a polygon that connects all four of the paws, and then you just look at the area covered by those paws, the area over time as it gets bigger and smaller can also tell us some some interesting features. These can be useful for certain use cases, head scanning, spine curvature, and so on. So these are yet to be implemented. But in the future iterations, keep an eye on the GitHub repo. I will be updating it within a few months, or maybe sometime shortly after that. So that's it for this video. Hopefully this is a short video. Leave me your comments below if you have any. If you find any bugs in this code, please feel free to reach out to me on GitHub so that I can track what the issues are in each repository. Thank you so much for your time, and hopefully this was educational for you. Bye-bye.